Welcome to another requested work solution. Today we're going to be looking at question 14 from the May 2014 Time Zone 1 Paper 2. And what we have here is we have two bisecting lines. So we've got 2 points on one of those lines. We've got point A, which is 5, 10, which is at the position 5, 10, and B, which is at the position 13, negative 2. There are 2 points on line, so this is our line AB, and the perpendicular bisector of the line AB has a gradient of 2 over 3. So a perpendicular bisector, so first of all we're talking about this line here, and we've got this other line here which is perpendicular to the other line. We know it's perpendicular, well, we've been told it's perpendicular, which means that that's a 90-degree angle, okay? And it's a perpendicular bisector, which means that the line, this is bisecting AB, which means it is crossing AB right at the middle of AB. So this here would be the midpoint, all right, of AB. And it has a gradient of 2, 3. So we've been told the gradient of this line here. Find the equation of the perpendicular bisector of AB. All right, so we're looking for the equation of a straight line. So we're looking for something in the form of y is equal to mx plus c. Now, we were told that the perpendicular bisector has a gradient of 2 over 3. So we already know our m component. We already know that y is equal to 2 over 3 x plus c. So all we need to know now is what the c part, or the y-intercept is of our perpendicular bisector here, this line over here. Now, we can only do that if we know a point on the line. If we know a point on the line, on the one that we're looking for, then we can substitute those values in, okay, and then solve for our unknown, which is c. And thankfully, because we know 2 points on the perpendicular bisector of the line, we can actually find its midpoint. And if we find the midpoint, then that is a point on our line, and we can substitute that point into our equation over here. So how do we find the midpoint? Well, what we're going to do is we're going to find the average of our x coordinates and the average of our y coordinate to give us a position on the line, or to give us the midpoint. So to find the average, we're going to say that we'll get 5, okay, plus 13, all right? That's the x component of A and the x component of B. So the midpoint, well, is going to be 5 plus 13 is 18, divided by 2 is equal to 9. And then we're going to find the between 10 and negative 2 for y. So we're going to say 10 plus negative 2 divided by 2. So 10 plus negative 2 is going to be 8 divided by 2 is equal to 4. So this midpoint here is going to be our x component here, which is 9, and our y component here, which is 4. So now we know a point on the line. We can substitute these values here, and then we can solve. So we're going to say that 4 is equal to 2/3 of our x component, which is 9, okay, plus c. So we have an equation, we have one unknown, and we can solve for that one unknown. So if 4 will be equal to 2 9s are 18, so we're going to have, and then 18 divided by 3 will be 6 plus c. So c will be equal to, let's get rid of that 6 on this side, so it's going to be 4 minus 6 minus 2. Therefore, the equation of our perpendicular bisector is going to be y is equal to our gradient, which is 2 over 3, minus 2, which is our y-intercept. So let me just highlight the answer there for you. So this is our perpendicular bisector here. If you would like anything to be clarified, or if you have another question that you would like me to do a work solution for, please comment down below, and thank you for watching.